Today we're going to learn about a process called completing the square. Completing the square is eventually going to help us solve more quadratic equations. But before we talk about how we're going to use it to solve quadratics, what we really need to do is see what that process looks like. As you can see in this first statement, completing the square is a process of writing an expression in terms of a square of a binomial. Now, before we get into this lesson, I'd like to talk about what the square of a binomial is more specifically so that you know what it should look like when you get there. So I'm going to go to another page here, and we're going to discuss the square of a binomial. Now, at this point, you should be very familiar with a perfect square. Excuse me. A perfect square trinomial. So if you look at an example like x squared plus 4x plus 4, perfect square trinomial should have a factoring pattern here that you should be familiar with, and it's x squared, x and x to get break the x squared up, and 2 and 2 to break up the 4 on the outside. Now, something that you should know by now is that this sign tells me that the two signs are the same, and the interior sign tells me what those signs should be. So, with a perfect square trinomial, we get the same two exact terms, x plus 2 times x plus 2 in this case. And so, since we have the two exact same terms, we can write those two terms as a squared value. Now, since this term is a binomial and is being squared, this is what we're referring to as a square of a binomial. So you can see here that the perfect square trinomial can turn into a square of a binomial after it's been factored and consolidated. So, if we had something similar, another perfect square trinomial, but in this case, we had negative 4x and then plus 4, that would factor into x and 2 and 2. We know that the signs are going to be the same because of that value, and in this case, they're both going to be negatives. So our square of a binomial for this one would be x minus 2 squared. Now, understanding how to get from a perfect square binomial to a perfect square trinomial to a square of a binomial will be an extremely important process in this set of notes as we go through the process of completing the square. Now let's just look at this in a visual manner. If we had an expression that said x squared plus bx, we could actually see that expression in a visual manner right here. Just like the boxes that we filled out when we were factoring in previous lessons, here we have x times x and x times b, and we get these two boxes. Now if we decide to split up the bx portion, you can see that we split this portion and bring it down below, and it creates this kind of incomplete box, or if you will, an incomplete square. Now when we split the bx, we can really write that as a fraction of b over 2 times x. What we want to do is, what value actually completes that square? Now, what this square actually represents is the standard form of a quadratic. So the ax squared plus bx plus c is represented by the square itself, and so that means that the c value actually has to be represented by the b over 2 square. Now this is just a visual example of what we will be doing when we complete the square mathematically. And so you can see that the b over 2 squared actually completes this square visually. So let's take a look at how that works mathematically. If that last remaining piece represents C, you can see here that the C value, which goes right there, can also basically be represented like this. C equals B over 2 squared, which was this value right here. So what we want to do in this case is find a value for C, because as you can see here, when we complete this square, what we've actually done is created a perfect square trinomial. And when we complete the square with a C to create a perfect square trinomial, this allows us to create a square of a binomial, which we talked about on the previous page. So this is actually the process of completing the square. You've seen it visually, and now you see it mathematically. So we're going to go through this process in an example. Example number 1 asked us to find the value of C that will complete the square. So since we've seen that C actually is equal to B over 2 squared, we can then plug in the B value, -7, in here, and then we create a situation where the square is applied, the square is actually applied to both parts of the fraction, and giving us 49 over 4. So in this case, the 49 over 4 would actually represent the C value. Now keep in mind, however, that the square of the binomial is actually represented by x plus b squared. And so you can see here it's x minus 7 over 2 in parentheses, and we're going to square that. So that is the square of the binomial. Now, what we want to do here is learn this simple process very well, this process called completing the square, because what it will do for us is it'll help us in the next stage solve quadratic equations. So you can see here in sample problem 1, they're asking us to complete the square for x squared minus 3x plus c. Now you notice in the last example that b value was an odd number. When it's an odd number, it's going to actually give you a fraction. And I know that it's not always easy to work with, but you need to be comfortable with working with the fractions. Now, if you're fortunate, you'll actually get an even number as the b value, and of course that c value will work out evenly. But in this case, we have a -3 as our b value. So, we want to complete this square first. And so instead of writing the c, I like to write just a big blank. And we need to figure out a way to fill in that blank. And so here we're going to take the little formula that we've learned that represents c, which is b over 2 squared. In this case, b is -3. When we square both parts of this, we're going to get 9 over 4. And so this is going to be 9 over 4. So 9 over 4 completes this square, which means it creates a perfect square trinomial. Now, let me show you both steps of the factoring process here. What this technically means is that if I were to factor this, it would be x and x and 3 over 2 and 3 over 2, because we know that 3 over 2 and 3 over 2 times each other actually equals 9/4. The plus value tells me that the signs have to be the same, and the middle sign tells me that they both have to be negative. Now, we have x minus 3 over 2 and x minus 3 over 2, so we have the same term twice. So we can write that as a binomial squared. Now, what we would like you to be able to do is recognize that this perfect square trinomial turns into this square of a binomial using this value of -3/2. And so if you recognize this, you will actually be able to skip the factoring step, which is what we would like you to get to be able to save some time when we go into solving quadratics again. So if you pause this video and work the sample before I did, hopefully you did, you'll now understand the completing the square process, and so in the next video we'll actually look at how we use that process to solve quadratics.